What's up, everybody? Welcome back. Math Unit 5, circles. Today we're looking at worksheet 506, calculating surface area of a cylinder. All right. Hopefully it's not mean this time. Get it? Mean. Sorry. I can't help myself. Okay. Back to the topic at hand, calculating surface area of a cylinder. We are looking at a cylinder. That's actually just a chunk of steel that is solid. The thing that makes it a cylinder would be if we were to make it hollow, right? But this isn't, it's solid. Whether it's hollow or solid, at this point is irrelevant to us, because what we're looking at is the outside surface area, which means the outside diameter. So we need to know the outside of the circle. So if it is skinny or has a thickness, that's not super relevant to us as long as we can find the outside diameter of the object. In that case, the formula, what we're looking at is, because we're dealing with circles, we are of course dealing with pi, right? We know that number, so pi times something. In this case, we're thinking of the red circle. What is that red circle? What is this? What if I go start at one end and go all the way around this circle in the same direction? What am I doing? What is that getting me? And the answer is the circumference. That is the circumference of that circle, or the cylinder in this case, because it's round and tall, it's a cylinder. So how did we get circumference? What was circumference? Go back to unit 501. Worksheet 501 tells us pi times, the red is going to be times diameter, right, equals circumference. Okay, awesome. So we're looking for pi times diameter is circumference. Then we're thinking surface area, Kevin, surface area of a cylinder. Okay, well, pi times diameter is the circumference. So we know the distance around the object. And then if we know the distance height-wise of the object, how tall it is, then we have another thing that we can do. So it's going to be circumference times height, okay? So if we were to draw that out in one easy to remember formula, it's pi times diameter times height. That will tell us surface area of that cylinder. And surface area is just the outside area of the whole object. So if we wanted to paint it, or if we needed to coat it in primer, or if we needed to weatherproof it in some kind of weatherproof spray, or if it was formwork that we needed to oil something, we're looking at the surface area, a coating of some kind, typically. In this case, we can just go ahead and we can start entering our numbers, right? We've got pi, which is on our calculator, 3.1459. I don't even know. It goes on for an infinite amount of time, times the diameter. And what is the diameter here? We see it as 0.7. So that's easy, times pi 0.7. It's already in meters, so I don't have to convert. And the height is 4 meters. So pi times 0.7 times 4. Pi times diameter times height. All right. Well, that's pretty good. That's easy. Let's go ahead and use the calculator, Matron. 7 times 4, and we get 8.7964593. That's it. That's the surface area. I don't know what else to tell you. You could round. 8.796. That's the answer. Okay. And because we're talking about an area, it would be in meters. So the area, surface area, meters squared or feet squared if you're an imperial. Let's go ahead and look at another example and see if we can figure out. If a concrete water tank is 80 feet tall, okay, so first thing I'm going to do, I know I'm dealing with surface area, so it's pi times diameter times height, right? 80 feet tall, okay. Pi times 80. And 20 feet in diameter, okay, times 20. So I've got the H over here and the D over here, and that is totally okay. We can reverse those two and it won't change anything. So if you just write out your equation right away, not a big deal, not gonna change anything. If a concrete water tank is 80 feet tall, so pi times 20 is our circumference, and then times 80 feet tall gets us a schwacking huge number, right? Because we're doing 80 times 20 times 3 point something. So she gonna be big. And the answer is 5026.54826. And that is in feet, because we're doing feet, 80 feet tall, 20 feet high or wide, sorry, and that's feet squared, round to the nearest cubic foot. Well, that's not happening. Round to the nearest square foot there, question guy, because a cubic foot doesn't exist for square, doesn't exist for surface area. That is supposed to say square foot, not cubic foot. So feet squared, sometimes there's errors in the question. So 5027, it says to the nearest 5027 feet squared. So I just drew a line, and the 5 makes the 6 round up to a 7, 5027 square feet. So 5,027 square feet is the surface area of an 80-foot tall water tank. My Lord, that is a lot. So I got another one written out here because now we're thinking about different diameters. We talked about different diameters. So now what happens if we're dealing with a pipe? In our previous examples, there was nothing that had a thickness, right? Now we're dealing with a thickness. So we've got a culvert. Maybe it's going underneath a ditch and we need to rig it and pull it out or something of the sort. I don't know. I don't know what you need to do for work. That's your business. I'm just here to teach you. Okay, so there is a round culvert pipe, possibly. And it would also be round on this side. My drawing skills are improving and still heavily lacking, but that's okay. The pipe is going away from us, apparently. So it is 10 meters in length. Okay. And it is 10 millimeters thick. Okay. 10 millimeter thick. And has an inside diameter of 1.2. Okay, so it's 1.2 inside diameter. Aha. So we need outside diameter in order to get a surface area, because it's saying surface area in the question. I need outside diameter. So I have a 1.2 inside diameter and a 10 millimeter thickness. So what's 10 millimeters in meters? I need to match this is meters. Our question, sorry, both in meters. We have 10 millimeters thick. So what is that divided by 1,000? And the answer is 0.01 meters is our thickness. So 1.2 plus a thickness on this side and a thickness on this side. So 1.2 plus 0.01 plus 0.01 equals 1.22 meters thick. And now we're back to an OD, an outside diameter of 1.22 and a length. But if you stood this up, it would be the height, right? We can think about it as length or height are the same thing. So it's pi times diameter times length, which is really just the same as saying height. This object is just laying down. Instead of being a column, it's a beam. Instead of being a caisson, it's a culvert, right? We're just laying it down. So then we can just put our numbers into the equation. We have pi. That's going to stay as a constant on my calculator. I have the diameter. My diameter is 1.22. And I have the length up here as 10. Perfect. or my height if that was vertical. It's the same idea. Okay, so pi times outside diameter times 10. So that is the circumference times the length, and we get 38.32743037 meters squared. Or we can just call it, maybe we only needed it as 38 meters squared. Maybe the question, it doesn't say in the question, maybe it's a quiz and we're accustomed to just doing to the third decimal, 327 meters squared. I don't know which one it's looking for, so choose your favorite. Just remember, if you are doing a quiz or a final exam, to read the directions and answer according to what the directions are asking you. But that's it. That's all she wrote. So pi times outside diameter times length if it's laying down, or pi times outside diameter times height if it's standing up. And that will get you the surface area if you need to coat the object in something like paint or oil or weatherproofing or who knows what, carpet for all I know. Enjoy yourselves. Have a great rest of your day, and I'll catch you on the next one.